day, grade 8 learners. In this video, you are going to learn about operations on rational algebraic expressions. Now we're going to discuss about Module 5, Lesson 3. Adding and subtracting similar rational algebraic expressions. What I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of adding and subtracting similar rational algebraic expressions and add and subtract similar rational algebraic expressions. What's in? Remember once again the operations on fractions. So we have here multiplication, division, addition, and subtraction. And in this lesson, we're going to focus about addition and subtraction. Let's try this example. Addition of similar fractions. So how are we going to get the answer for 5 over 4 plus 3 over 4? So in adding similar fractions or fractions with the same denominator, all we have to do is just to copy the denominator and add the numerator. So we will have 5 plus 3 is equal to 8. And just copy the denominator, which is 4. So we got the answer 8 over 4, and we can still simplify this one. So the answer is 2. So we just divide 8 divided by 4. And always take note that you have to always express your answer to its simplest form. How about if we are asked to subtract similar fractions? So we have here, for example, 9 over 4 minus 3 over 4. In subtracting similar fractions, just like addition of similar fractions, we just have to copy the same denominator. So the denominator here is 4, so we just have to copy that one and just simply subtract the numerator. So we have 9 minus 3 is equal to 6. Or as we simplify 6 over 4, we will have 3 over 2. Once again, take note, always express your answer to its simplest form. So what if our fraction will evolve and will now involve literal coefficients? Just like this problem, what's new? U minus v over 8v plus 6u minus 3v over 8v. So how are we going to get the answer? How did we get the answer 7u minus 4v over 8v? Did we just follow the same steps in adding similar fractions? So as we proceed to this lesson, you will be able to find out. What is it? So how to add and subtract similar rational algebraic expressions? We have to remember this. In adding or subtracting similar rational expressions, add or subtract the numerators and write the answer in the numerator of the result over the common denominator. So in symbols, we have here a over b plus c over b, which is equal to, so a plus c as the numerator over b as the common denominator, in which take note b should not equal to 0. Let's have this example. 2a over ab plus ac plus 3a over ab plus ac. So following the rule, we will be able to get 2a plus 3a, which is the numerator, over, just copy the common denominator, which is ab plus ac. And let's simplify. So 2a plus 3a is equal to 5a over ab plus ac. We got 5a because because they have the same literal coefficient. So in other words, we just combine like terms. So 5a over ab plus ac can still be simplified. So we just have to factor this out. We will be able to get 5 times a over a times the quantity of b plus c. So let's check. So using the distributive property of multiplication, we can get a times b is equal to ab. Then a times c is equal to ac. So they're just the same. Now we can cancel out a in this case. So therefore, the answer is 5 over b plus c. Now let's have this second example. Subtract x squared plus 3x plus 2 over x squared minus 2x plus 1 minus 3x plus 3 over x squared minus 2x plus 1. So following the rule, we can also just write the numerator with this. It will become x squared plus 3x plus 2 minus the quantity of 3x plus 3 over, you just copied the common denominator, x squared minus 2x plus 1. And applying the distributive property of multiplication, we can distribute negative. So it will become, so negative times 3x, and we will also distribute negative to positive 3. So our new equation will now become x squared plus 3x plus 2 minus 3x minus 3 over x squared minus 2x plus 1. And now we're going to simplify this one by combining all terms. So we can cancel out 3x and negative 3x because 3x minus 3x is equal to 0. And we can also simplify our constant 2 and negative 3. So we will be able to have 2 minus 3. So we will get negative 1. Therefore, we can have x squared minus 1 over x squared minus 2x plus 1, or we can also write it with as the quantity of x minus 1 squared. Take note that x squared minus 1 over the quantity of x minus 1 squared can still be simplified. So for x squared minus 1, we just have to factor this one using the difference of squares. And for the quantity of x minus 1 squared, we can also expand this one using the FOIL method. So we will be able to get the factor of x squared minus 1 is the quantity of x minus 1 times the quantity of x plus 1 over the factor of the quantity of x minus 1 squared. We will have the quantity of x minus 1 times the quantity of x minus 1. And we will be able to cancel common factors. So we have x minus 1. Therefore, our answer will become x plus 1 over x minus 1. Now, let's try answering this activity to check your knowledge about adding and subtracting similar rational algebraic expressions. So what's more? Directions. Answer the activity below to measure your understanding about the lesson. Use a separate sheet of paper for your answers. Activity 1.3. Find the sum and difference of the following similar rational algebraic expressions. Number 1, x minus 2 over x minus 1 plus x minus 2 over x minus 1. 2, 7 over 4x minus 1 minus 5 over 4x minus 1. Number 3, x squared plus 3x minus 2 over x squared minus 4 plus x squared minus 2x plus 4 over x squared minus 4. Number 4, we have m minus 3n over 6m cubed n minus m plus 3n over 6m cubed n. And we have the last number, 5. 5 over a squared plus 3a plus 2 plus 5a plus 1 over a squared plus 3a plus 2. I know you can do it. Once again, just remember this rule in adding or subtracting similar rational expressions. Add or subtract the numerators and write the answer in the numerator of the result over the common denominator. In symbols, we will have a over b plus c over b is equal to a plus c over b, in which b is not equal to 0. This quote from David Justice will end our lesson about adding and subtracting similar rational algebraic expressions. You get what you focus on. So just focus answering our mathematical equations. I hope you learned something from this lesson.